All right. So, good morning, afternoon. Good afternoon, everyone. Everyone hear me? All good? Nice. Excellent. Thank you so much. Oh, I love to hear a response from people. That's fantastic. It shows that you haven't eaten too much for lunch and haven't yet fallen asleep. My name is Jeremy. From PubNub, we sponsor the event in part. We're downstairs. We've got a booth. I hope you can drop by later, but I'll give you a reason to drop by, okay? Somebody came up to our booth about half an hour ago, and they asked me, I don't know if he's here. Is Akmal here? No? He said he would come. So he came up to me and he asked me, he said, my startup is having difficulties because we've created an application and my developers they're inexperienced, right? And the way we're doing things is we have a server and my developers have created an application that is constantly asking the server for data even when the server doesn't yet have data. And I said, you definitely have to come to my talk later because this is the most common anti-pattern. It's relatively an elementary anti-pattern. You probably learn about it in computing school when you're in second year or third year or something like that. And yeah, and that's usually solved with something, well, PubNub solves it for you really well. But I'm going to talk a little bit about real-time applications today. We're going to talk about what real-time applications are, why they're important. We're going to build one, design one in real time. Sorry, I cannot build a full system within half an hour. All right, design one in real time. And then what we're going to do, as I design this in real time, I'm going to make 3 mistakes. 3, all right? Your goal is to try to spot them, and towards the end, we'll talk about the mistakes I made and how you might solve it from an AWS point of view. Good? Excellent? Nice. Let's do that. Oh, right. So yeah, that's the agenda, yeah? Why real-time matters. We'll talk about the scaling difficulties of it as well, and then we'll design one in real time, and we'll talk about the pitfalls, yeah? Excellent. So why do real-time applications matter? I'm mindful not to stand in the way of my own slides. Why do real-time applications matter? Perhaps we should start with what are real-time applications, right? So real-time applications are all around us. We use them every day. We've got them on our phones in our pockets. And the most common one that you'll find is chat. Now that's not explicitly written there because chat is often not just chat. In applications like WhatsApp and Telegram, chat is just chat. But in many applications, chat is embedded into it. It is a part of it. For instance, in gaming, right? A gaming application, which is a game, if it doesn't have chat, it loses that layer of socialness, that layer of engagement, right? And that is something that if you build a game that is multiplayer without chat, I've seen people do this. Half a year later, in fact, 3 months after launch, they come running to a chat provider saying, please give me chat. People were excited about my game, and then they're bleeding out. Once the game has lost excitement for them, they leave. So that's chat, right? So that's in gaming. Internet of Things. Someone again came up to the booth earlier downstairs. They said, we've got manufacturing devices, and these manufacturing devices are sending reports about their health, about their status, and we also want to control these devices. How do we do that? Internet of Things, that's an Internet of Things kind of use case. We also have situations where there are a whole fleet of logistics vehicles out there in the wild. And out there in the wild, these logistics vehicles need to constantly send back things like location information, things like how many miles it's driven, health statuses, again, check-ins on this kind of thing. Again, real time, because often you have a dashboard somewhere where someone is sitting monitoring these sorts of things. They want to know where the vehicles are and how long more they'll take before it reaches a warehouse or a processing facility. Every hour lost in a truck carrying valuable materials, I've heard, and this was in Indonesia actually, can cost tens of thousands of US dollars, yeah? So the last one is things like collaboration. Collaborative use cases are incredibly common now, especially in this world that we live in where people aren't necessarily in the same place, right? Today I've had the opportunity to travel here to Jakarta to speak to all of you, but in many instances I haven't. I've had to collaborate with people across the world right? And do things like edit documents in real time together. So if you've ever had a document editing experience, whatever that is, like if you do Google Docs or something like that, where you're seeing the other person is online and they're typing and you can see them type at the same time as you, that is real time. That sort of thing is powered by an infrastructure just like that. So that's why real time is important. We see it all day, every day in our lives. We may not necessarily think about it. And implementing and building this sort of thing is perhaps a little harder than you might think so. These are what I call, these are challenges. It's written here as challenges, but what it really is requirements. People need these things out of real time, and building it is not easy, right? At its hardest, you need high scale. You need to be able to handle millions of messages and devices all at the same time. And that's super not easy. Like all of you are, you're here because you're interested in AWS and you've tried to scale things, and it takes expertise, right? So you need to do these all in low latency as well, because I had a conversation again with, it's been a productive morning, again with someone standing downstairs. I told them, hey, if I were to stand next to you and I send a message to you, and you have the same messaging application open, if you don't see that message show up on your phone immediately, how annoyed would you be? And he answered, yes, of course, super annoyed. We expect these things in real time. Even if I'm standing next to you, I know this message needs to go out to some server somewhere in the middle of nowhere, come all the way back to your phone, and that still has to happen in under 100 milliseconds, or I get super annoyed. That's low latency, right? Global reach. We collaborate with people all over the world these days, and messages are sent, when you play, oh gosh, I don't play games anymore. I shouldn't have used this example. When you play a game, whatever game that is, right? You expect to jump into the game, play with people from across the world, and be cursed out in multiple languages, correct? Yes. So we need global reach. It can't just be that your applications are only performant in a local environment, right? So yeah, that's what's needed. And building that out, again, a challenge. Reliability. Yeah, well, it needs to be up to work. Yeah? When things go down, things are on fire, and that's always a bad thing. So let's talk about how we solve these things. We're going to build together, and by together, I mean I'm going to lecture you about it, right? We're going to build together a real-time system, all right? And again, I'd like you to keep your eye open for 3 mistakes that I make that we're going to solve with AWS, all right? Cool. But let's talk about PubNub, because that's what we're going to build it on, right? PubNub is a real-time platform on which you're going to be able to have the infrastructure to deploy that sort of real-time workload, right? Send and receive messages all over the world, low latency, high scale, and super simply, just integrate an SDK that we provide into your application, whether it is a mobile device, web app, server-side as well, and you should be going within 10 minutes just to get started, at least. Cool. Nice. At its core, quick show of hands if anybody has, and I'm assuming you have, but quick show of hands if anybody has heard of PubSub. Wonderful, thank you very much. At least one of the hands is one of PubNub's developers sitting at the front. Great, which is fantastic. So publish and subscribe. If you're unfamiliar with it, when you send a message, yes, you indicate what this message is about. And the people who subscribe to this message, they sit back, relax, and the people, and when I say people, I mean devices, sit back, relax, and they receive the message based on the fact that they have subscribed to these messages. They have said to the server, hey, I'm interested in messages of this sort, please send it to me. So pretty straightforward. So let's say you're building a chat application, yes? This chat application may be standalone. Maybe you're trying to build a new Slack or something, right? Or it might be something that part of whatever application it is you're building. If it's, some of you might be interested in becoming the next fintech stars. In your payment application, you might want to have chat. Why? Because people send and receive money to each other these days in a chat framework. They say send, request money, and then it says receive, right? So let's start with that. Publish and subscribe. Great. Nice. I realize the code is a little small. For those of you seated super far back, if you want to see some of this, you might come a little forward. Later we have diagrams as well. The font only gets smaller from here, right? But if you sit in the front, I promise you I will not pick on you. So what we have here, user 001, publishes a message. It says good morning, and the subscriber is user002. Straightforward. I say good morning to you. All clear, right? If you have questions, you can stop me at this moment. Nice. Great. Part of the publish and subscribe way of thinking, it's the model of how things work, is that when you publish and subscribe, there's always a kind of a subject, right? What this is about. In PubNub land, we call it a channel, but for those of you who have used MQTT, you might be familiar with the term topic. It's the same, right? What I'm saying is when I send a message to you, you can identify it on this channel, which means when you want to subscribe to it, you subscribe to this channel. Let's say in this instance, we have published and subscribed on channel 001. So far, so good. Makes sense, right? Yes. Channel 001 is how I say to you, good morning. Good. Nice. And in this instance, I have also decided to add a server that's subscribing. Why? Because part of the way publish and subscribe works is that publishers and subscribers are completely decoupled from each other, which means you can have as many people subscribing as you need. This is how a large chat room works. Chats aren't just 1:1. In case you have, what's super common these days is live commerce, right? So if you have like somebody, influencer of sorts saying like, oh, buy this, buy that, it's fantastic, it's great. And then you have a chat that's getting super excited at these products. They're saying, please please tell us what the discount code is. Yep. So you can have user 002 and then user 1000, all of them listening to this. Or in this case, I've put a server there. Why does a server need to listen to messages? In some cases, a server is interested in moderating the messages or doing analytics on it. Moderating is super important for things like gaming. Yes, if you ever build a game, please, I beg you, if you ever build a game and you do chat, please put moderation inside because nobody wants a toxic environment in games, yeah? Cool. Nice, so we have a server listening, we have a user listening on channel 001, everybody gets the message, good morning. We've built it in real time using PubNub. All we had to do, let me go back one slide, was to do one line of code, publish and subscribe. Great. The next time I come back to this chat, I also want to see this message, right? So how do I need to do that? I need to add in a layer of persistence to store the message. Good. So as I add this layer of persistence to store the message, all I need to do is, in fact, switch it on, all right, on PubNub. And in that case, I now have persistence. As the message is published and subscribed, it automatically stores. You, of course, get to choose different levels of retention here, like how long you want to save it for. In this instance, I have chosen unlimited retention. I save it forever, right? So that whenever I want to in the future, I can come back to this living message that we have sent to each other, which is good morning. Good. Nice. Have you ever sent a message to someone and stood around and wondered when they're going to reply? Yes? Somebody who, let's say you're desperate for a reply from this person. Yeah? I recall doing that a lot in my youth, but back when I was young, back when I was young, we didn't have presence indicators. Now we do. That's great. SMS didn't have presence indicators. Now we do. When I open up WhatsApp or Telegram, I can see you have a green circle, you're there. I send you a message, you'd better reply me soon. If not, I'm going to get super angry and send you another message on Instagram. So that's what presence indicators are about. It's tracking whether you are online or offline, whether you are connected or not. In a large chat room, you could be tracking how many people are there. So when you open up your game and you go to your guild or your something like that, and then you see, 15 out of 20 people are here now chatting. That's what that is, yeah? Presence indicators. So again, we build it in real time. By the way, everything I've said so far, applicable to IoT, applicable to collaboration as well. I'm using chat as an example here because it is an incredibly common use case and one that everyone instinctively understands, yeah? Good. So now we have green circles, yes? Let me point out again. Green circles indicating, yes, the server is listening to you, it is online, it is up there. User 002 is also listening. You have sent the message, good morning. Good morning, yeah, good morning. Over channel 001, you are saving it, unlimited retention, And you also have user 003 who is offline. I've added the offline character to indicate to you, yes, people can be offline. By the way, when they come back online, they will need to go to persistence to receive this message to pull it. Yeah? Good. We're building this in record time. Nice. What's the next thing we're going to add? Ooh, I forgot to, oh yeah, it's there. App context. Good. So far, so good, right? We've added user 001 talking to user 002 on channel 001, which is great, except nobody knows what any of those things mean. Who is user 001? Who is user 002? What is channel 001? We don't know what that means. And in a naive way of building this, if you were to, because by the way, it's super common, like user 001, like when you normally assign an ID to a user, you're not assigning them their full real name. You're assigning them something from a database that you pulled out, a UUID, right? And that's barely pronounceable at all, right? And then channels-wise as well, you're usually pulling something from a database. It's unique, it works, fantastic. But then when I talk to you and I get the message, I don't want to see user 001. What I actually want to see is what your name is. So application context is super important, and we store this metadata on live, at the edge for you, hot, so that you are able to retrieve it and put context to all of these messages that are being sent through PubNub. Great. We continue to flesh it out. Fantastic. Now we have user 001 is me. My name is Jeremy. This is my email address, all right, and subscription gold, right? In case you want to charge subscription for your app, yeah, you can add these things as well, right? And then Bob at example.com, subscription silver, right? So we're adding context to this. You can even add context to channels. Channel 001, name soccer buddies. So now I play soccer with Bob. Yes? Good. Anybody has soccer buddies? No? Me neither. I'm too old for it. So, good. Oh, functions. Anyone familiar with AWS Lambda? Thank you so much. The more of you familiar with it, the less I have to explain it. Functions is similar to Lambda. It's not a competitor, but it is similar. So, serverless functions execute. Yeah, serverless functions execute. You paste your code in it. You don't have to manage scaling or anything. They execute on request whenever you want it to. Perfect. The difference is that for PubNub functions, they are triggered by messages being sent through the network. Yes? AWS Lambda triggers on different things. You can set it, you do all kinds of other things, but for PubNub functions, that's what happens, and it is, most of the time, when you use a PubNub function, it's related to your real-time workload. That's all it is. Yeah? Now, what can you do with it? Remember I said moderation? That's another super important thing. When I send a message to you, you want to catch very quickly whether I've said something nasty, whether I have said something I shouldn't say, or maybe I'm the one being scammed. What if I send you credit card information? Oh my goodness, that's terrible. You immediately want to cut that out. You want to detect that and cut that out. Right, so that's what a function can do. It can immediately do this. It can send it out to a third-party service to do, everybody's favorite thing these days, AI, right? Look at it and come back to say, yes, what's the percentage confidence that this is something that you don't want? Boom. So let's illustrate this flow once again. I have to come so close to the screen. My name is Jeremy. I'm sending a message, good morning. But I want this to be translated before it reaches my friend Bob, who only speaks Bahasa. It goes out into a function that says, hey, translate this please. It goes out as good morning, comes back as selamat pagi, comes back all the way, and when it's finally published, it's selamat pagi. All good, right? Please tell me I've also gotten the Bahasa correct. Thank you so much. Right. Nice. It's starting to look like a pretty complicated system, all right? But so far, you don't even yet have to worry about anything. All of this is automatically managed and scaled for you. Great. Events and actions. Events and actions is pretty straightforward. It is a way to take everything that's happening inside of your real-time system that we've just built and send it out into anything else you want, right? This other thing can be, back towards AWS. It could be to your own servers. It can hit a webhook. It can do all of those things. So, for example, let's say when I send a message, you want to notify a partner, on a webhook that Jeremy is now sending messages. And the reason you're doing this is because Jeremy was presumed to be a dormant customer, and now you notify this partner and they can start sending me with the newsletter again. Kind of spammy, but let's allow it, all right? So how would you do that? Again, right here at the bottom, everything is going through, except that now when the message is sent, it triggers also events and actions, and it's hitting a webhook. All of this can be set up. By the way, events and actions is set up in a no-code way, so perfect, right? It's hitting this partner webhook, and that's done. Good. I want to just check my next slide. Okay, fantastic, because I don't want to give you the answers yet. Good. So we've built this system. I know I've gone pretty fast so far. I want to give 1 minute here for everyone to think about whether you have any questions for me about this. Super fast questions. Okay, great, nice. Good. In building out this system, I have intentionally made 3 mistakes. If there are more than 3 mistakes, one of them is unintentional. Right, so I'm not going to make you guess. Instead, I'm going to flash up the diagram one more time. 20 seconds to look at it. Good? All okay? Nice. I am going to highlight the first mistake. The first mistake is probably the biggest one when it comes to scale. I've put a server that's subscribing using an SDK, right, to all of the messages being sent on all of the channels. It is the biggest mistake because it works. I say that again. It is the biggest mistake because it works, at least for a while, yes? When this scales, you're going to have difficulty. One server receiving all of the messages in all of the chats, in all of the systems. Your instinct is to scale up. And yes, you can. You can scale up to a degree, yeah? But machines only get that powerful, right? And then you're going to be forced to scale out. But the problem with scaling out is that if you do it this way, if you do it this way and you start to add add more servers, you're going to have difficulty with all of the servers still receiving the same messages, not being able to get the messages, yeah? Not being able to decide who is supposed to process which message. Now, the solution to this is to use events and actions to send these messages to AWS, put it into a queue, into SQS, yes? So, I've been informed I have like 5 minutes left, so let's do this real quickly. Nice. So instead of that server there, now we are pumping the messages via events and actions into SQS, and you have a bunch of auto-scaling workers depending on your needs for latency, for throughput, right? Picking up these messages and doing the workload moderation, anything else you can think of. Yeah? Good. Let's go through the second mistake, nice and quickly. Oh, no, I don't want to reveal the answer. Second mistake is, all right, let's tell you the answer. Unlimited retention. Unlimited retention is fantastic if you need it, but a lot of people don't, and they still, oh, well, let's save it forever. The problem is that unlimited retention on PubNub, at least, is stored hot on the edge everywhere around the world for you to retrieve in real time. But as data gets older, it becomes useless, something you're continually familiar with if you're using S3 as well. So this is my recommendation. I see people constantly not keeping track of their channels, by the way, and they're coming back to me and saying, oops, I have all of this data being stored. Instead, right, use events and actions again, send it to S3. So the solution now is I put my persistence 30 days retention, and using events and actions, again, no code, yeah? Just put the link there and chuck it into S3 for archival. You choose your tier, you get to decide how much you want to pay for that kind of thing as well. It's completely separate. So, fantastic. Nice. I'm going to give one last mistake here. All of this is related to scale. The more, these are things that work when it's smaller scale, but when it gets bigger, you're going to have difficulty. Last one. 3, 2, 1. The channel name, right? Channel 001 works for now. And then you have channel 002 and 3, and then channel 1000, and you say, well, it's unique. You can have as many channels as you want, which is fantastic, except it's not, because you're not going to be able to figure out which channel is for what eventually, right? And you're going to have difficulty assigning privileges to these channels. You're going to have difficulty, you don't know what the channels are for. All of these things exist. So what you really want is a channel that's easy to programmatically reconstruct based on its purpose, that is regexible. I wanted to say easy to regex, but that's never easy. Yes, and then easy to wildcard, which means, well, on PubNub land, you can do like a .star to wildcard this sort of thing. It's logical and organized, and you can keep track of it at all times. Let's finish off today's presentation with one last part. Chat.user001 and user002 is the channel that I would prefer for this sort of use case. Yes? Good. Nice. I think I'm just on time, given that I started a little late, but let's see here. We've built a real-time system. We've solved 3 common pitfalls. Yep. And I think we're good to go here. Yes? Is there anything the organizers need from me? Before we finish, yeah? Are we good? Q&A. Okay, nice. Oh God, I didn't think of a Q&A. Let's do a quick Q&A. Q&A, I'm going to ask for a raised hand for what is the problem with using a server with the SDK to subscribe to messages versus using events and actions to send it to SQS so that your auto-scaling workers can pick it up. That's the very last 10 minutes we've discussed. It should be fresh on your mind. Could I get a raised hand just to quickly answer it? No hands. Okay, let me ask an easier question. The easier question here is, what is the name of that PubNub thing up there that translates the message for you? Could I get a raised hand? You get to win stuff, by the way. Thank you. Shout it out loud. Functions, thank you very much. Yes, so how do I give the gift? Okay, great. So yeah, I think that's it for me. If you have questions about anything I've spoken about today, if you have any part of your application that you're building that is real-time or otherwise, come to talk to us. We have a booth downstairs, yeah? Thank you so much. Thank you, bye-bye.